Hi, my name's Dylan. Welcome to the 6th lesson on linear functions. By the end of this lesson, you should be able to describe the way in which output values are affected by a change in the values of the constant. To start with, we're going to refer back to the example from lesson 1. The charge for calls is 80 cents per minute, and the line rental is 20 Rand per month. Do you still remember the formula we set up? Here is the formula. Y is equal to 0,8x plus 20. Remember that the rate of change is 0,8 because Telecall charge 80 cents per minute, and the constant is 20 because the line rental is 20 Rand per month. Now think about it. Many prices are changed annually. So Telecall may decide to increase their line rental from 20 to 30 Rand a month. How would this affect our total cost? Well, let's use a formula to find out. Remember that the input variable x still refers to the duration of calls. The function g describes the total cost when the line rental is 20 Rand per month, and the function h describes the total cost when the line rental is increased to 30 Rand a month. And I'm just going to use convenient values for x. I'm going to use 10. So when x is equal to 10, we have that g of 10 is equal to 0,8 multiplied by 10 plus 20. So therefore, g of 10 is equal to 8 plus 20. So finally, we have that g of 10 is equal to 28 Rand. In other words, a total cost of 28 Rand. That's for the initial cost where the line rental is 20 Rand. Now, when the line rental increases to 30 Rand, we're going to use the same input value of 10. So h of 10 now becomes 0,8 multiplied by 10 plus 30. Therefore, h of 10 is equal to 8 plus 30. So finally, we have that h of 10 is equal to 38. In other words, a total cost of 38 Rand. Now look carefully at these two output values. Let's choose a duration now of 100 minutes. So in this case, our input value is 100, so we're working with g of 100, which is equal to 0,8 times 100, which is 80, plus the line rental of 20. So g of 100 is equal to 100 Rand, our total cost. H of 100, that means when our input value x is equal to 100, is equal to 0,8 times 100, which again is equal to 80, plus the line rental of 30. So h of 100 is equal to 110, our total cost of 110 Rand. Did you notice the similarity? The output value for the increased cost was 10 Rand more than the output value for the initial cost. And once again, in this instance, the output value for the increased cost was once again 10 Rand more than the output value for the initial cost. But this is logical, as the only thing that has been increased is the line rental by 10 Rand. Can you predict how the graphs of these two functions will be different? For the function h of x is equal to 0,8x plus 30, the increased cost function, the rate of change is 0,8 and the constant is 30. Let's look at both graphs on the same set of axes. In lesson 1, we plotted 2 points and then joined them in order to draw the graph of the function g. But now in this series, we have learned how to draw a straight line without having to necessarily plot 2 points. So remember, for the increased line rental, the function h of x is equal to 0,8x plus 30. So first of all, we know that the y-intercept of this graph is at 30. So we know that this graph is going to cut the y-axis at that point, 0, 30. Now the rate of change, as we can see from the formula, is 0,8. But you also know that we can write this as m, or gradient, is equal to plus 0,8. Therefore the gradient is equal to plus 8 divided by 10. Therefore the gradient is equal to plus, if we simplify this ratio, we're going to get it down to 4 divided by 5. Remember, in lesson 5 we said that it is easier to work with the rate of change that is written as a common fraction. So in this case, we know that for every 1 unit that the x values increase, the y values must increase by 4/5 of a unit. Or another way of saying this is that for every 5 units that the x values increase, the y values must increase by 4 units. Let's take a look at our graph. We know that we need to move right in the x direction by 5 units. So we're going to start at our starting point here of 0, 30. This is the point where x is equal to 5. We know that we need to move up in the y direction by 4 units. So we're going to move from 30 to 34. And 34 is approximately here. So this is our new point. This is where x is equal to 5 and y is equal to 34. And I can simply join these points with a straight line. And there is the graph of my function h. Now, look carefully at the slopes of g and of h. For each of the straight lines, the rate of change is 0,8. On the graphs, we see that the lines are parallel. Now this is logical, since the gradient determines the slope or direction of the line, and the gradients in this case are the same. To move the graph of g to h's position, we can see that we have to move or shift the graph of g up 10 units. So, where x is 0, for g, y is equal to 20, and for h, y is equal to 30. Where x is 25, for g, y is equal to 40, and for h, y is equal to 50. All the points on a graph make the formula for the graph true. So all the output values of g move up 10 units to fall on h. Remember, all the points on a graph make the formula for that graph true. So in other words, all of the output values of g move up 10 units to fall on h. Let's reflect on what we've learnt. We know that the general form for a linear function is y equal to mx plus c, where m is the gradient and c is the constant. Now, if we change the value of c while keeping the value of m, or the gradient, the same, then we can see that the slope of the lines remains the same, but what does change is that the line is moved up or down. Now, such an up or down movement is called a translation of the graph. Let's get back to our example. Let's say, for example, that Telecall have a special offer. If you install a line within the next 30 days, you will be charged a line rental of 15 Rand. However, your calls will still cost 80 cents per minute. Now, what is this going to look like on the graph? Well, let's check. Instead of cutting the y-axis at 20, we're going to move 5 units down so that the graph cuts the y-axis at 15. So this is the first point. It is the point 0, 15. But we also know that this graph has the same gradient or rate of change of 0,8. And as we've already calculated, 0,8 is equivalent to 4 divided by 5, which means that we need to move 5 units across in the x direction and then 4 units up in the y direction. So our second point lies over there, and all that we need to do is join these 2 points. And there we have the graph illustrating the function where the line rental has been decreased by 5 Rand. Remember that for this new function, every output value is 5 units less than the output value for g. So I could shift each point on g 5 units down. So on g, when x is 25, y is 40. So for the decreased phone line rental, the y values will be 5 units less. In other words, this y value will be 35. For each function, the rate of change is 0,8. Remember, we said that the lines were parallel. Now let's confirm what we mean when we say that the lines are parallel. For any input value, the distance, the vertical distance between the lines remains the same. So from this input value to this input value, the vertical distance remains the same. In general, we can now look at a simple linear function, for example, y equals px or p times x. Now, all other functions with the same gradient will be translations of y equals px. P refers to a specific value for the gradient. Of course, I could use any symbol. Now, px means that the gradient remains the same for this group or family of translated functions. Because the gradient is the same, the graphs of these translated functions will be parallel. Now let's have a look at some translations using y equals 2x as the parent function. This is the graph of y equal to 2x. Let's move the graph 3 units up. 1, 2, 3. The formula is y equal to 2x plus 3. What happens when we move the graph 4 units down? The graph moves 1, 2, 3, 4 units down, and the formula is y equal to 2x minus 4. Now, look at the graph of y equal to minus 3x. This is called the parent function. Now, which graph is y equal to minus 3x minus 5? Can you see that it is the green line or the graph of f that has moved 5 units down? All these graphs are family. The gradient is the same, but the lines have simply been shifted up or down. If you can predict these shifts and write formulae to reflect these shifts, then you have understood what we've done in this lesson.